So thanks to the panelists. I really appreciate you coming out here and sharing some of your thoughts with the audience today. So I've got a few questions to kick off, and then we'll be getting questions from the audience. So I'm going to have two themes for these questions. First is on the technology side, but the second theme is just as important as the technology is the policy side of things. So let's start with the technology first. So future warfighting concepts are pushing the limits across many technologies, and the systems engineering challenges are huge. How do those challenges translate to the defense industrial base's ability to manufacture these systems affordably? So why don't we go with Lane first?
Well, I think today things are going faster than ever, and there's also a lot of systems interaction that needs to happen. And so I think the application of smart analytics is where I think we can unleash a lot of value add and productivity in today's current environment. And how do we kind of, we use our cell phones in our everyday life. How do we do that in the manufacturing space so that we can take advantage of increased first-pass quality and real-time data that we can use to adjust kind of the production system that's producing those aircraft?
Mick?
So I think from a systems engineering standpoint, the technologies are coming on so quick, and the ability to be able to adapt them to actually producing a part is going to be a major challenge.
Okay. Ralph, anything to add?
Yeah, to follow up on, I think, what Mick's saying, the need for us to develop both materials and process physics-based models that will allow us to have a better understanding of how we transform materials into products.
Ben?
I would like to make 3 points very quickly. The first one is I think we need a very skilled workforce. Okay, so the workforce development is going to be a choke point for the future of manufacturing. So that's number one. Number two, how do we create a system where the small, medium-sized companies are willing to join in the supply chain innovation? They're willing to participate and also benefit from this innovation throughout the entire value chain. And the third one is cybersecurity, because in the future, a lot of manufacturing going to be in the digital world. So I think the cybersecurity is going to be extremely important.
Charles?
Well, I think sometimes, to be a little provocative, I think sometimes we get a little too much lost in the engineering. And we have these huge numbers of opportunities, but the question is whether we can capture them for this economy and for this military-industrial base. So I think we need to recognize that the scale of our investment needs to be increased, actually dramatically. There's a lot of talk about manufacturing now, but it would be useful if we invested in it, and if we invested in the whole cycle, not just the basic research. We've talked, John and I have talked about the need to perhaps have a foundation that focuses on manufacturing rather than just on science, as the NSF does. But we also have a lot of opportunities that are out there right now with the Manufacturing USA centers. These public-private partnerships have value in themselves, but they're also the path forward. We really have to work hard in breaking down these silos between what's in the public sector and what's in the private sector. We cannot afford that. And just a last point, I don't want you to think that I feel passionately about this, but I just think that the scale, there's no football team. I'm in Texas, so this may make sense to you. There's no football team that plays on a Friday or a Saturday that hasn't watched a film of what its opponents, how its opponents play. We are basically playing blind. Most people don't even know what the Fraunhofers are, let alone what their budget is. So we're putting in maybe 500 million into these manufacturing centers. Our friends in Germany annually invest $2.25 billion year after year. We have 15 proposed centers. They have 68. But of course, they're a third our size. So I think we just need, and I haven't even mentioned the Chinese yet, so I think we need to take a reset on where we are and what kind of competition we have.
Great, thanks. Next question. Let's pull on that string a little bit on the policy side a little more. So, you know, the last 5 years has seen the startup of the Manufacturing USA Manufacturing Institutes. You know, DARPA has made the use of grand challenges over the years to advance technologies. You know, what kind of innovations do we need in the way the Air Force does business in terms of contracting mechanisms or whatever in order to acquire those advanced technologies? Charles, if I can ask you to start since you started the ball rolling on this.
Well, sure. I mean, I am not sure, but I think the federal acquisition regulations must have been designed by the KGB. I could not think of any other reason that they would be in place. One of the things that's important to realize, and we were discussing this before the meeting, is that what people love about DARPA, rightly, is how fast they can move, how agile they can be on a good day. And the fact is, as a friend of mine in the Senate Armed Services Committee remarks, most of the agencies can actually do that. Most of the agencies have other authority. But they're careful not to use that because that would be too quick, too efficient, and too low cost. So I'm quite serious about this. You have that opportunity and we don't do it. And it's part of this mentality shift that I think we really need to address in this new administration.
Okay, thanks. Anyone else want to field that?
Sure. If you're talking about institutes, as you know, I've been engaged in that in one way or another. And I think that Chuck hits on it very well. We have this mechanism of this new concept of accelerating innovation in manufacturing. And we have an acquisition system that is slowing down that acceleration. So the institutes have been looking at other transaction authorities, cooperative agreements, and so on. But still, even in that, the acquisition system is taking, in some cases, 6 to 9 months to get things under contract. If we really want to see, and to tell you the truth, the technology is moving faster than that. So we're not being able to get in front of it and to be able to exploit and maximize that. There have been a number of initiatives that have been put in place at DoD, like better buying power and so on, that on the surface are well-intended. But once it gets down into the execution levels, it's really looked at as a way to reduce risk and to be adverse to risk. So I think what we need to get back to is the partnership, not just in the manufacturing institutes, but we need to remove this this filter, this buyer-supplier filter within DoD, and have more cooperation between the primes and the acquisition community, and to be able to not be confrontational, but to be supportive and collaborative.
Okay. Anyone else have a thought?
I'm not going to knock the acquisition cycle that much. Of course, it could be done faster, and everybody has the same opportunity to do other transaction agreements and have the same opportunities to speed up and be at DARPA speed. I think a lot of the issue has to do with it, when you talk about manufacturing, look out over the next 100 years, it's not just technology. I mean, manufacturing is kind of that where you get economics, regulatory, technology, including materials, engineering, and design, and they all kind of intersect at one point. when we talk about ManTech and what we're trying to develop in the R&D side, a lot of what the problem is extracting out what that technical piece is and being able to work that. Once you've done that, the actual transition, there's so many other issues that pull into that I think, we need to really rethink how we go about doing that. So to me, it's much more than just the technology piece, but it's the policy, the regulatory environment that we're in. And it's, when you look at some of the technologies that you talked about over the next 100 years, it's what are you going to do with the people when you start talking about autonomy? How do you handle all those people that potentially could be putting out of business? And so, speed and regulation, I think is going to have more to do with how you handle those non-technical issues than you do the technical.
Okay. Ben?
Well, I don't really have a lot of comments on the contracting systems because compared to some of the contracting system at the university, the Air Force contracting system actually is very good. What I would like to comment is now we have 14 the Manufacturing Innovation Institutes. Each one specializes in one particular technology, additive or digital manufacturing. I was part of the original design team for the Advanced Manufacturing Partnership, and this is something that we did not actually foresee. Now we have 14 great institutes. Each one has a very specific technology focus. I think going forward, what we need is perhaps a few demonstration sites to show how these technologies come together and work seamlessly in a fashion that will help companies of different sizes.
Okay. All right, let's flip questions here. We got one for the audience that lines up really well with another one of my questions is, so what is that next big thing in manufacturing? So we're on Industry 4.0. What is Industry 5.0? What should we start thinking about now to get ready for 10, 20 years from now? Lane, you want to deal with that?
Well, yeah, I kind of getting back to, I really think about, how do we get away from a shimless manufacturing base? When you talk about marrying technology and items like additive and subtractive and using the state of the art, how do we get to a point where we can basically get away from having to think about engineering in shims? And more importantly, training an engineering workforce that understands the shadow they cast in production and in manufacturing aircraft and weapon systems. So I'm a big fan of kind of the leveraging today's technology and not necessarily being handcuffed to the way we've always done it. And sometimes it's very tough. And I think additive is one of those great areas where it's met with a lot of naysayers. It's not the end-all solution. But boy, when it comes to shortening the value stream and complexities for free and thinking about how do we get closer to near-net parts, I think it's possible within the next 10 years.
Okay. Anybody else want to jump in?
Yeah, so I kind of think of things in when you talk 100 years, near term, mid-term, long term. And for me, when I was at DARPA, that near term is kind of what my portfolio looked like. So it's really about integrating the computational tools, being able to go across disciplines. So, right now we think about computational tools for design, computational process tools for manufacturing. Really, it's going to be that integration so that the design tool suites begin to work seamlessly. The second thing is when I think about what's specific to the Air Force and DoD, is we really have a problem in trying to develop rate-independent processes. The fact is that you can be a terrible customer. In fact, that I want 100,000 of these things next year. I might shut that production line down for a year or two, and then I want 100, and the year after that, 1,000. So that being able to get processes that are rate independent, I think, is the next big focus. The midterm, I actually see that as being integration of autonomy, and that's everything from machine learning to the human-machine interface. Right now, when we think about autonomy, we have a section that does autonomous systems. That's where our robots work. And then the next station is where the people work. We've got to be able to get those to work together to make the best use of both systems. Now, there's going to be a lot of, I mentioned before about, hey, there's things that are non-technical. Where do you ethically draw the line between machine learning and the human-machine interface? That's going to become a big issue and challenge that, frankly, we're not equipped for from a service lab point. And then the long term, I see the reintegration of the human. So if I think about 100 years from now and the type of manufacturing we'd be doing versus what we did 100 years ago, I see moving manufacturing into the hands of the warfighter. So if you want to really think out of the box, some of the programs that were being developed at DARPA in the same office I was in had to do with the brain. What if we could get the warfighter to think about what he wants to use? Those guys are constantly modifying what we send overseas anyhow. What if they were actually able to think about what they wanted to create and then have that built? Give them the computational tools to be able to do that. And so, we're going to probably spend 50 or 60 years getting the human out of the loop, and then probably those last 30 or 40 figuring out how to bring them back in.
Interesting. Okay. Ralph?
I think that when you talk about what will be the next generation, not necessarily what's going to be the next generation of manufacturing, but I think something that we have been pursuing for some time and the implications of everything that contribute to it, and that is first part and every part correct. So that means that we have to understand coming out of whatever manufacturing process it is, that we have to have a thorough understanding of those processes, those unit processes. That we have to have a thorough understanding of what the materials are like and how they're going to behave. You mentioned the fact of the LCAT and being able to do something that is not going to be so susceptible to qualification and certification. But I think we need to be looking at expanding upon the work that Mick did, was sponsoring with regards to virtual validation and certification, and how we can be using the virtual world more before we go out and start doing our final testing. So I think the mantra of first part and every part correct is something to really strive for.
Okay. Let's jump topics here. We've got a couple from the audience dealing with additive manufacturing. So, Ralph, I'll point to you since you're so knee-deep in it. How long, if ever, do you think it will take for additive manufacturing to replace conventional manufacturing and actually fly fracture critical parts on airplanes? What do we need for that? What do the standards need? Those kind of things.
Well, there's a multitude of things that we need. In America Makes, we worked with our consortium partners. We worked with the different services to come together, put together roadmaps to define what the critical elements were that we needed to pursue, and there are many. Number one, I want to say that I don't see additive manufacturing replacing conventional manufacturing. There are many things that we can do with additive, and I'll be the first one to say that it's not appropriate for everything. I mean, we'll be able to do significant things in the future of being able to, manufacturing processes used to be a bottleneck when it came to the whole supply chain. Now manufacturing is enabling design, is enabling new materials and functionally graded materials and so on. And that evolution is going to continue. But I think we need to be not concentrating on what can additive replace, but where we can exploit the inherent capabilities of additive and really be focusing on that. And Ben, as you're saying, part of that is education from the standpoint of understanding those opportunities with additive and designing for additive where appropriate. But there are many things we have to overcome. The whole qual insert and being able to get, but again, I think we can get there by understanding the process more, by having more in-process controls, by doing more in-process certifications. And we're seeing that happening now, and will continue to advance. But additive is a very complex process because we're not just transforming a known material into a product. We're a foundry, we're a welding shop. It's everything. So there's a lot that needs to be worked out, but I think we're seeing very quick advances, and I think within the next 3 to 5 years, you'll be extremely surprised at what's happening.
Okay. Ben, how about you? I know Georgia Tech is looking at the next generation of additive. How do you weigh in on this?
Well, first of all, I agree with Ralph completely in that additive will not replace subtractive. And I see the future of manufacturing is going to be a hybrid system. Additive, subtractive, digital, analog, cyber, physical, human and the robots together. Okay, so coming back to additive, I used to have a list of 12 challenges in order for additive to live up to its potential. I don't remember all the 12 challenges, but I remember from the materials, from the process, from the equipment, design for additive, qualification, certification, all the way to the business models and regulatory challenges. I think there are really about a dozen major challenges we really need to overcome in order for additive to become part of a component in our toolkit.
Okay. Anybody else want to jump in?
I think definitely we need to exploit where it makes sense right now because, like I said, one of the beauties of additive is sometimes shortening the flow. So think about building tools. Tools tend to be the bottleneck when you're building new programs. Complexity for free. When you talk ducts and vents, things of that nature, engine parts. One area that I think we need to get serious about, don't get me wrong, I think there will come a point, maybe 50 years out, where you'll go into the Smithsonian and see a 3-axis machine and look at it like you would a typewriter. But I don't think we're near that anytime soon. I would say we ought to use, as an industry, use additive as a way to do something different. When I say that, qual insert, let's go after part families instead of individual parts. I mean, this is an area where there's just a lot of waste and time that goes into, if you've got a process that we can get down to specifics and that's controlled via pretty much automated processes, why can't we lean forward a little in how we qual insert additive components over hand laid up or conventional milled components? I think there's something there that we need to kind of lean forward as an industry in order to make happen.
All right.
Here, here.
Yeah.
Mm-hmm. Let's switch back over to policy side again. I got a couple of questions along the same lines here. So what kind of policy or regulatory changes need to happen in order to improve weapon system affordability? Should we, for example, allow defense companies to share in those cost savings that we get from these R&D innovations, for example, or anything like that? Charles, you want to jump in?
Well, I'm glad you raised that. I think the affordability is, it's partly, there was a time in my life when I worked in IT, and, one of the problems is sometimes the user. There's complexity after complexity with constantly evolving requirements. And one of the things I think you need to do is to shift the incentives. I was very much struck by in your talk, among the many good points, where you talked about using a swarm of lower cost but highly efficient drones. That type of opportunity where you're using, in effect, the principles of mass production, but at a high-tech level, I think, unfortunately, I think some of the things that our Chinese friends have been working on suggest some fundamental flaws where you have equipment that is so expensive that it becomes prohibitive. But what's a little bit troubling is that we have known about some of these problems for some time. So we continue past the flashing yellow lights down the same path. And I think one way to change that is to change the incentives inside the organizations, but also outside. If we want to have the primes work more closely, for example, with promising companies, the whole field of SBIR type firms, well then give them major incentives to do that. And those incentives should be financial, but those incentives should also be reputational. I mean, people do what they're measured on. There's a whole line of things there. If we want more rapid adoption, you know, we have this growing problem that the things we invent here are not produced here. And the whole beauty of the additive manufacturing is that we should, and these other new institutes, is it's an opportunity to reshore very large amounts of our manufacturing base. Not to try and take away what Taiwan is building today, but build things in Ohio that were built there before, but with new ways. And the tax system is critical. We have a window here where if we get in, not just, you know, let's pay as little as possible and run for the door, but a tax system which encourages investment, really encourages investment, not a grudging depreciation, but one that fits in with the product life cycles. I'm sorry, I can run on that, but taxes, I worked at Treasury for a while, and the enduring lesson is that taxes drive behavior. So get more generous with the companies and encourage them to do things financially that need to be done.
Ralph?
We have 300,000 manufacturing organizations in the country. And DOD is working with about 10% of that. We have a lot of innovative organizations, a lot of efficient organizations that don't want to do work with the government because it's cumbersome, it's complex. We need, and I'm not attacking the acquisition system, we need to find ways to be able to engage these non-traditionals, these small companies, to bring them to the table, to embrace their innovation, and to have them be providers to our defense base. So whatever way, whatever barriers that we can break down, I think would be very appropriate from a policy standpoint.
Okay.
So I was actually going to say, you know, when we talk about the acquisition, everybody has the same warrants, the ability to put out the same contracts with the same kind of speed. You want to do something really to help things is train your acquisition officers. Because basically, when I was in the government, both at Army Research Lab and DARPA, depending on the acquisition officer you had, really determined the speed at which
That's true.
you got the program put in place. So, you know, yes, it is a little bit more cumbersome because, you know, we do have to worry about things like security, and that system was put in place over a number of years of learning as you went forward. But having a more consistent way in which those rules are applied, I think, would go a long way.
Ben?
If we broaden the definition of the weapon systems a little bit more, going beyond the discrete part manufacturing to include the biomanufacturing, the biologics, or even the biological cells, stem cells, and then there's a lot of regulatory issues that we have to deal with quickly. Right now, the technology is way ahead of the regulatory the pathways. So I suggest the DoD working with FDAs and other government organizations is to come up with a regulatory systems really is to accommodate a wide range of different manufactured parts.
Let's see, switching gears. So we heard a lot today already throughout the program about Industry 4.0. There's going to be a panel tomorrow about cybersecurity. you know, what are some of the challenges for the defense industrial base to implement Industry 4.0, the digital thread? What do we need to do about cybersecurity to make sure that our defense industrial base is secure and not susceptible to either data theft or sabotage? Lane, you build airplanes for a living. Well, let's start with you.
Well, yeah, I mean, it's a serious problem because in one file you basically have, especially when you start integrating with things like additive, you basically have the secret sauce that if it ends up in the wrong hands, you lose all of that, that IP. Not only that, but I mean, even within our own factories, they're so noisy these days. You mentioned manufacturing has you know, we have libraries of Congress of data coming off the 8.7. So it's really how do you focus on the vital few areas and drive hard to make a difference with just those vital few. This is one of those areas where we're going to run in 20 different directions, and there's going to be a lot of non-value added activities that's frankly not going to allow us to benefit. And this is where I think, you know, you see some basic analytics happening right now. Uber is the largest taxi cab company in the world and owns no taxis. Airbnb is the largest hotelier in the world and owns no hotel. They're using very simple apps focused on a couple of data points in order to drive a business innovation. And I think we within manufacturing just need to think about Internet of Things is cool and we can Wi-Fi everything, but should we? And I think that's where, depending on the application, we need to be very smart about what we're enabling, both from a security standpoint, but frankly from a productivity standpoint. Because we're engineers, and engineers love the 99.9995% solution, and we don't necessarily care about the whole business aspect of why we do it. So I mean, that's my 2 cents anyways.
Okay.
I think the cybersecurity part is obvious. The next thing is basically a dilution of data. You know, as you get, you know, on the open manufacturing program, when we were just doing one additive manufacturing build, we were generating terabytes of data. As you begin to try to extract and do your analysis to, you know, extract information from that, you begin to make assumptions and you begin to abstract from that. I worry about in that dilution of the data that we end up losing key insights that across a larger database we'd actually begin to learn from. You know, there's going to be a fine line there between where do you abstract versus where do you simplify so the human can absorb it.
Anybody else? Ben?
Not so much on cybersecurity. Mike McGrath is an expert on cybersecurity, so I think you can ask Mike a lot about cybersecurity. Coming back to Industry 4.0, I think we are in the early years of Industry 4.0. If you look back the history of industrialization, each stage lasted about, I would say, between 80 and 100 years. Okay. So we are just at the beginning years of Industry 4.0. It is hard to predict, okay, what we will see at the end of Industry 4.0 or the beginning 5.0. But I think it's fair to say that the future of manufacturing, like I said, is a hybrid system. Many different technologies. So I think the interface between different components is going to be very important, the interface. Okay. The second thing is the standards. To set up standards for the future of manufacturing. Right now, the process of setting up a standard is really very time consuming, very slow. Okay. And the third one is, I believe the Industry 4.0 is not the end in itself. It's a means to an end. I think each company will have to figure out what the end objective is when they reach 4.0. So what is the business case? And how do they monetize? How could they monetize their investment in the different technology?
Okay. Charles?
I'd just like to pick up a point that Ben made earlier that also reflects the public-private partnership paradigm. You know, I think there's a growing recognition in the country that we have not spent enough time on vocational training, not spent enough time on manufacturing. The people in this room can actively help to change the perception of manufacturing in the high schools. Believe it or not, I remember people who came to visit our high school and talked about things they were doing. And that kind of stuff can have a huge impact. We've got a 50-year outdated view of what is manufacturing, and the partnerships, and there's a good model of this up in in the Albany region in New York, where companies like Global Foundries is cooperating very closely with Hudson Valley Community College. You know, you have two options when you're an executive. You can either complain that we don't have enough trained people, or you can help train them. So I kind of like the second option. And there again, by the way, Siemens excels in this, but their CEO here said that they get huge tax advantages for their contributions in Germany. They don't get the same thing here. So again, incentivize corporations to make these contributions, and on their own, I think it's obviously in their interest to make this type of close cooperation, but early on.
Okay. Another question here. So a lot of times the first thing we hear about a new material or manufacturing process is the best thing you ever hear. It looks like a nice juicy steak, but once you really learn about it, it's more like a crappy McDonald's hamburger. How do we change that? How do we get better insight into our materials and processes sooner? How do we accelerate the insertion of our materials and processes a lot faster? I mean, I know Darva's made a couple runs at that, but it seems like we're still on the two-decade mindset. What do we really need to do to kickstart a better way to get new technologies into systems? Oh, Nick?
Yeah, so as a culture, we tend to get attracted to the shiny object. And so one of the things that you've seen, at least in my career, is, you know, the hype that is associated with a new material or manufacturing process basically sucks up all of the R&D money, because the agencies want to be relevant. They want to be able to answer the question, what are you doing in this technology or that technology? The problem is we didn't finish all the work that needed to be done on the last shiny object to actually get it adopted and build the confidence to do that. I don't think we're going to be able to change who we are as a people. But what I talked earlier about being able to integrate across, integrate the computational tools across disciplines. Now, in building those computational tools, there's a certain rigor that has to be done. There's a certain amount of information has to be developed. And if that's part of the S&T when we're still infatuated with the shiny object, now the database is there and the ability to use that material and technology is available for when the platform comes along. So a lot of what we did on the MDP program was kind of getting at that, is how do you get that material database to tie, and those design tools and material tools to tie in with the design tools.
Yeah, I think that there is, and again, this is where the beauty of the institutes, or the vision of the institutes and Manufacturing USA was to take was to accelerate the transition of the science into the engineering, and to bring the academics and the researchers together with the industrial commercializers. And that's a new dance. I mean, there are companies that work with the academic institutions and work very well with them. But getting the rest of the manufacturing supply chain to understand the wealth of information, the wealth of expertise in our universities that other countries have identified and are willing to exploit is something that I think we need to be better at. And I think we're getting better at it. And but there's that's the way that I think we can accelerate.
Okay.
I'll come back. Again, it's about being able to build the rigor in there to develop the information. You know, while something's hot and you're getting money put into that, you know, I'll take a pot shot here, but we shouldn't be printing cars, right? We ought to be able to be taking that money and understanding the process more. We build too many hypey demos versus doing the hard work that's necessary to get the information.
Ben?
Two quick thoughts. Number one is to follow the TRL, MRL paradigm religiously from day one and all the time. So that's number one. And number two is the massive use of ICME tools. I mean, the Mick just mentioned. I mean, these two are critical.
All right, here's a question that none of us may be eligible to really answer, but what skills do millennials have that are essential to the future of defense manufacturing? With all of us being Gen X or baby boomers, I'm not sure we really understand the minds of those millennials, but what do they bring to the table?
Well, I mentioned earlier, I mean, most of us in here run our lives off our cell phone until we get into our manufacturing plant, at least I do. And I think that's an area, an application that we're missing in just manufacturing. How do we get kind of the app generation applied to manufacturing, whether it be first pass quality or design for manufacturing? I think that's an opportunity. And then the other piece that I've seen is just how do we leverage the fact there's no loyalty as far as they're interested in exciting projects, not necessarily being with somebody for the rest of their lives. So how do you move quick and nimble and provide opportunities at a fast pace in a very slow clock speed company? I mean, aerospace is, you talk about all these material systems, takes decades to put a material system into play, and they want to be in a 6-month cycle.
Yeah.
So,
yeah. Ben, you're with millennials every day, being in a university. What's your insight?
I don't know how much help I can provide here, but I found the new generations, the young kids are extremely bright. What worries me is their attention span is so short. Okay, so in order to keep them interested in a subject long enough so that they can study the fundamentals, it is very challenging. Number one. Number two, even though they can communicate with the electronic devices really well, very fast, but I think the basic writing, speaking skills are still necessary. Okay, so those are really the very important challenges that we face.
Ralph?
One of the things that I've observed is their extreme capability for visualizing and understanding in 3D space. So maybe playing all those video games is not so bad, but they can pick up solid modeling. At a very young age, we see this being happening when kids are in elementary school. So I think that understanding of 3D space is something unique.
I'm going to say, when you hear people complain about millennials, a lot of those traits are what make a great DARPA program manager. I mean, we all have short attention spans. But the fact is I think they're able to handle a breadth of knowledge rather than go deep on a subject. And you're in a manufacturing environment, the ability to not just understand your field, but understand all the other fields that are in play, I think they'll actually make great manufacturing engineers.
Charles, do you have something?
Well, I think the point that Ralph touched on is their ease in the whole ITC world is a huge advantage, and in one way is that they're able to look at things differently. They're often impatient, and I think they're impatient because they do see ways of doing things faster, better, cheaper, and the opportunities to get them to listen to them as they come into an organization and try and talk about how you could do things better is really important. I mean, that's an advantage we have in this country, is that it's not perfect, but our communication vertically, I'd rather be in an American company, even a large one, than in a large German company, let alone a German university. I mean, there's still plenty of places in Europe where they walk in, they read their text to the students and walk out. It's not really too interactive. So that's why a lot of people come here.
Okay. So that's a good segue into the next segment, next question. So how do we improve university-industry research cooperation like the European entities in Germany, like the Fraunhofers, for example? Charles?
Well, we've talked a little bit about this. I don't want to keep repeating myself, but I will until we do something. One is to keep the assets we have, which are research universities. We're so fearful about the future of the world that we've cut funding for them on a per capita basis by 20% over the last 10 years. That's our contribution at the state level to the knowledge economy. A second thing we might do is reinforce these institutes. A third is to provide these incentives I've talked about. Don't just lecture people, but provide incentives to do that. A key thing that and Ralph and I have not talked extensively before the meeting, but a key thing is patience. You know, the Fraunhofer was started in 1949. You know, they've been at this for a long time. They've built a brand and they've built capability. One of the things we need to do more of in each of these areas, particularly in the 4.0 space, is to provide equipment that can do this virtual validation. There are different elements in our manufacturing centers, but one of them, which I think is still relatively undeveloped, is to use equipment, to provide equipment in an industrial commons where smaller companies can have access to expensive and difficult to operate equipment that will enable them to move up to the next step. It's also a place where they can draw on university expertise, and it's a place where they can meet potential partners. But that takes time, and we are notoriously bad at that, I think, in this country. But that long-term vision and creating greater recognition that not only manufacturing matters. I mean, there's this pervasive influence of what people call economists who try to explain that we don't really need manufacturing, and it's normal that we don't have manufacturing. It's curious that the rest of the world seems to want manufacturing, but we don't need it. So I think, and the other is to change this image internally of what manufacturing is today, which is still a very serious issue. People would rather send their son or daughter to a 4-year school, often not focused on a saleable skill, rather than have them come out of a 2-year college and earn $80,000 or $90,000 a year.
Yeah. Ralph?
I think one of the things that where industry can help with this interrelationship with academia is to possibly lobby or lean on NSF. People may not realize that we don't have an overabundance of National Science Foundation investment in manufacturing. In fact, manufacturing shares a division with civil engineering. So it doesn't even have its own bucket. And NSF gets a lump sum of funds from Congress without any discretion on how they spend that budget. So we can't lean on Congress and say, please have NSF do more work in manufacturing. It's up to NSF to determine that. And the only way that we can get NSF to do that is to try and influence them as to how important manufacturing is and how important basic research in manufacturing is. I think there's this tendency among some of our research community, at least the funding portion of things, is that there's no basic science anymore in manufacturing. And in fact, DARPA was out of the manufacturing game for many years until they got back in it, what was it, about 8 years ago?
2009, 2010.
Yeah. So we need to be having more of that basic research too, to be able to have that support structure in place to get more students into manufacturing and to be doing research in manufacturing.
I'll use this as an opportunity to complain about the decimation of the corporate lab. So, you know, we've basically kind of turned over a lot of the basic and applied research work to the academia. And then we ended up worrying about this valley of death. Well, you know, that used to be filled by the corporate lab. When you talk about policies that could be done, tax policy to encourage the rebirth of the corporate lab system, I think would be fantastic.
Yeah, you know, the Fraunhofers, you know, the one thing is, because we do a lot of research all over the world, and we do a lot of work with the Fraunhofers, as well as, frankly, the European universities. They tend to be higher on the TRL, MRL scale. They tend to be a lot more business friendly, IP terms, want to actually encourage and work with us. We haven't necessarily seen that from the US institutions, other than some really good ones like Georgia Tech and MIT and University of Washington. So, you know, in fact, we've got some labs in place in many of these universities. And you know, if the universities think about bridging that gap with us, focusing on the higher TRL, MRL, and also, you know, understanding it is business innovation we're talking about. So there's got to be some IP sensitivity. Otherwise, why wouldn't we just do it ourselves?
Right.
Charles.
You know, the Semiconductor Research Corporation model that the semiconductor industry developed, they weren't getting enough engineers in the semiconductor space, and they had questions that were out 5 to 10 years that they needed answers for. So they banded together and they made contributions, and they also asked that that be matched by the government, which it has been for many years. I think that type of model in certain manufacturing sectors, where it's not purely basic and it's not purely applied, but there is this cooperation, and it's also a huge advantage. I mean, universities have their failures, but if you can get professors off the 6-month or 9-month cycle of raising money and let them actually do work over a 3-year cycle, enough to run a PhD candidate and into a postdoc, and have them working with industry, I mean, that is your workforce. People don't understand the Fraunhofers are a huge workforce development, not just the technology and the incremental improvements. So there are models out there, and we need to watch that film.
Yeah.
Ben?
2 points quickly. Number one, I would like to have Ralph to be the director of NSF to change the culture.
All right.
You know, seriously, about 10, 15 years ago, manufacturing was not a pretty word at NSF. I mean, it is true, manufacturing share the same division with civil. All right, so I think that culture, that recognition of the importance of manufacturing should change at NSF and other organizations as well. And also to follow up on Len's points about universities working on the translational work, Georgia Tech is a large engineering school, so we do a lot of basic research on campus. We also do quite a bit of translational work, but in an ad hoc manner, not structured. But in recent years, we begin to build a structure to encourage translational work. So the basic research is done on campus, but the translational work is done near campus, the facilities near campus, where companies can come in and work with professors and students together. So the 3 principles for the translational facilities. Number one, it has to be TRL, MRL 4 to 7. So that's number one. Number two, we have to have students embedded in the factory. So that's teaching factory concept. And number 3, it must have the commitments, long-term commitments of companies to work with the university. So those are the 3 design principles.
All right, let's go back to the technology side. So, you know, in my talk, I described this game changer of autonomy, having robots and people working together in warfighting. Well, you're hearing a lot about that now in terms of cobotics and man and machine working together in the same manufacturing cell. How is that human-machine collaboration and assisted human operations going to impact the next generation factory? Lane, you want to take that one?
Well, it's already primary in Boeing's factories. I mean, unlike the car companies, we don't have production lines that have 45-second tack times and 1,000 positions. We've got a couple dozen positions, and it stays in position for 4 to 8 hours. And so it's impossible to not have the marriage of mechanics and some types of either automation or even assist mechanisms. And so we're working on technologies where, there are robots out there today that you can work alongside of them that are safe, that have visioning systems. And where that doesn't happen, we're having to put cages around them just like the car companies do. So it's interesting. We have got more constraints than a traditional manufacturer when it comes to automation, because frankly, we can't afford to put gates around all of our robots. We just don't have enough space in the production system. But at the same time, I think we're right on the cusp of robots that are able to do this work alongside the mechanic and work side by side. And we need that, frankly, in aerospace, not only in commercial, but even in defense, right? You mentioned flexibility and taking a robot that one day can be drilling and filling on a fighter and the next day be drilling and filling on a rocket. You've got to have that ability. I think it makes sense all the way around. So I think it's a win-win for aerospace, frankly, if we can get robotics that are able to work alongside humans.
Okay. Anybody else? All right. Next question. This might be hard for us, but so directed energy has been around for a long time. The joke is directed energy is the weapon of the future, and it always will be. Everybody, it's the weapon of the future, and it always will be.
Okay.
It seems to be that it's always going to be 10 years away. But people are starting to get more and more passionate about it, especially as we worry about our future threats and the fact that we may run out of bullets. We may be winning the war until we run out of bullets, and then we're in big trouble. What needs to happen in order to make directed energy a reality? What are those manufacturing things that we need to do as a country to move that ball forward? Any thoughts?
So I think you got to understand the technology you're trying to do. When I was with Army Research Lab, any technology we tried to put on the soldier that took away from his ability to carry bullets or water, they threw it away. If I want him to use a directed energy weapon, now I tell him, take away your 5 pounds of bullets, and you got to carry 10 pounds worth of batteries. That's a non-starter right there. So you got to think about what the technology requirements are going to be, and then then figure out how to manufacture it to meet the needs.
Anybody else? Okay. Back to more the policy side. So you see the Department of Defense now starting to reach out to the non-traditional community in terms of the DIUX, Defense Innovation Unit Experimental, and trying to work with Silicon Valley and working with startups. How can the DoD leverage startups and innovation for manufacturing, especially in aerospace, as risk adverse as we seem to be in this industry? Charles?
Well, I alluded to that earlier. I think making a better use of the SBIR program recipients, better use of the program, meaning to make sure that you're directing the calls to things that are truly needed. In the interest of being frank, the Air Force has been very ambivalent about the SBIR program for a number of years. In fact, some of them considered it the SBIR problem. I have tried to explain to colonels that the Congress constitutionally has the money and they allocate much to you and some to small business to work for you. It's not a tax, it's an allocation. But if your recent report is correct, you're achieving success upwards towards 70% of the time, which, if you'll forgive my humor, I find troubling. Because SBIR is best described as a game of basketball. In order to win, you have to shoot. One of the key determinants of success for a company is applying. So getting an effective outreach program, but also taking moderately risky shots so that there's some real benefit if the company is successful. But then the challenge, which is very real and also very understandable, as we were joking, if a company comes in and says, I can make this faster, better, and cheaper, the procurement officer says, what's your point? And why? Because his incentives are to go with the prime, go with the proven contractor, frankly, the contractor who will eventually hire me, rather than take a risk on a smaller company. But those smaller companies are where the ideas come from. And they have proven fantastically successful. You know, DoD doesn't get the credit it deserves, and I mean that. You know, everybody in this room has an SBIR product in their pocket. It's called a Qualcomm chip. Because DoD took a number of high-risk investments in Qualcomm in the mid-80s, mid-80s and late 80s, not because they thought they could do it, but because they thought it would be really good if they could. And that's what's driven this revolution that we have. So integrating those, providing incentives for program executive officers, I hate to say it, but the Navy, you've heard of the Navy.
I've heard of them.
They do a really, really good job, particularly in subs and view ships, in terms of integrating these SBIRs. I joke with you about the Navy because I once made that pitch to a group of people from the Army, and they looked at me and said, so what's your point? We're the Army. But in all seriousness, that's again an example. The follow-up on these awards is absolutely crucial. You mentioned that much depended on the program officer. And so training the acquisition officers, this is a broader topic, but as Jack Gansler likes to point out, we have taken, if I'm not mistaken, in acquisition, we've taken the generals out of the cone. We have cut that force by, I believe, a third, while roughly doubling its tasking. Some of our gentlemen here from business might be able to explain whether that's a good idea or not. So I think restoring both the quality and training and a career path for people in that is actually critical. These things matter. And I would hope, again, with this administration, with the push on additional defense spending, that might be an opportunity to recognize you can't push more and more through the same narrow funnel.
Right. Great. Right. So,
John, so one thing.
Last comment.
Yeah, okay. So one thing is, from an innovation, I think the term is often misunderstood and overused. You know, when I look at, not every technology has to be adopted. And really, you know, that's kind of where you see a lot of the IUX coming from is, oh, we let all this stuff sit and languish. Well, there's probably a good reason why it is languishing. One of the things I've always said is, you know, the valley of death was caused by bad applied engineering, nothing more. And so being able to go through that filter to figure out what is needed at the application end, if you do all the work that's necessary to understand that application, the innovation becomes easy. It's easy to adopt, and it gets adopted quickly. The problem is, a lot of times, the technology doesn't have the fundamental understanding to take it forward.
All right, so that concludes our time today. First, I want to thank the audience for all the great questions. Really engaging conversation. And I want to thank all the panelists, you know, Charles, Ben, Ralph, Mick, and Lane. I really appreciate your time. And thanks again to SME for letting us come here. So with that, thanks a lot.